Algebra students, as we continue to talk about polynomials, so you have worked with adding and subtracting and multiplying polynomials. That was our last unit. So you can add, subtract, and multiply polynomials. When you add and subtract like terms, when you multiply polynomials, you have to worry about all your exponent rules. We're not going to talk about division probably until Algebra 2. It's a pretty complicated process to divide polynomials, and it's actually not something we do a whole lot of. But what we will talk about is factoring. And that's what this whole unit is about. It's about factoring polynomials. And factoring is a way of rewriting multiplication. So when you take a number like 72, when you list the factors, you're listing things that multiply to 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18. 6 and 12, 8 and 9. So the word factoring, as it applies to polynomials, comes from this idea. We are going to be rewriting a polynomial as factors that need to be multiplied. So the first kind of factoring we're going to do is called GCF. Stands for greatest common factor. When you look for the greatest common factor, you're going to look at a polynomial and ask yourself, what do all the terms have in common? And the answer could be none, nothing. And then if the answer is nothing, then there's nothing to do and you're done. But let's take a look at an example. So if we review from today, this is a quadratic trinomial. The highest power is 2, so quadratic. Tri, because there's 3 terms. And when you look for a greatest common factor, you're going to ask yourself, what do these 3 terms have in common? And looking at all 3 terms, what I see is the number 4. 20 is 4 times 5. 16 is 4 times 4. 4 is 4 times 1. And so the way we work with the greatest common factor is we write the greatest common factor outside a set of parentheses. And the number that goes here is this first term divided by the greatest common factor. So this is 4x squared divided by 4 minus 20x divided by 4 plus 16 divided by 4. Now if we simplify what's in the parenthesis, we would get x squared minus 5x plus 4. And right now that's all we're trying to do is take out the greatest common factor. And so if you look what we've done, we've taken this quadratic trinomial, this polynomial expression, and we've rewritten it as 2 things to get multiplied. Now, a lot of kids will get to this point in the problem, and then they'll distribute the 4, and then they'll get back to what they started with. You don't want to distribute the 4 because the directions here say factor, so we're trying to get it to be written as multiplication of 2 things. Take a look at this next example. Give yourself a moment and see if you can find the greatest common factor. If you said 5, you're on the right track, but you're not completely there. Notice that this is x to the 4th, which is x times x times x times x. And this is x cubed. And this is x squared. Do you see that all of these terms also have 2 x's in them as well as a 5? So the greatest common factor is 5x. Let me just write this down here. 5x squared. Now, what goes inside the parenthesis here is this number divided by 5x squared. 25 divided by 5 is 5. X to the fourth divided by x squared is x squared. Minus 15 divided by 5 is 3. X cubed divided by x squared is x. Plus 4. 20 divided by 5 is 4. X squared divided by x squared is 1. 4 times 1 is 4. So again, you can check your answer. You could then multiply 5x squared times 5x squared minus 3x plus 4. If you multiply that out, you would get 25 x to the fourth minus 15x cubed plus 20x squared. And because I got exactly what we started with, I know that this is correct. Now, you got to be careful because just if you multiply it out and you get the same thing doesn't mean you got the answer right. So an example could be something like this. Let's just say 50x to the fourth minus 30x plus 40. Sorry, x cubed plus 40x squared. If you take out the 5 here, you get, 10x squared. Or 5x squared, you get 10x squared minus 6x plus 4. And while you did get a common factor, there's still a 2 that's left in here. So the greatest common factor would have been 10x squared, and then that would have left you here with a 5x squared minus 3x. That should have been an 8, plus 4. So you just have to make sure you get the biggest possible number that goes into both. Try this one. This one's a little more difficult, but see if you can figure it out. Okay, what's tricky about this one is there is no number that goes into 3, 5, and 4. So you don't have to take a number out. But this one has 3 x's, 4 x's, and an x. So x gets to come out of everything. This one has 2 y's, this has 3 y's, and this has 4 y's. So 2 y's get to come out of everything. This one has a z, this one has 5z. This one doesn't have any z's, so z isn't common to everything. So now what I'm left with is 3 x to the second z plus 5 x to the third y to the first, z to the fifth, minus 4 y squared. If you did it correctly, nothing inside the parenthesis will have, there won't be a common factor to all three. So this has 2 x's and this has 3 x's, but notice there's no x's here. This has a y and this has 2 y's, but notice there's no y's here. This has a z, this has 5 z's, but this has no z's. So we have taken out the greatest common factor. That's all we're working on tomorrow in class, taking out the greatest common factor from a polynomial. All right, peace.